Hey guys, this is Mr. Burns. Sorry that sorry, hold on. You guys want to meet my dog Cole? He's just hopping up and looking at me here. Sorry I'm not here today. This is unexpected kind of emergency came up. So this video is to introduce you what I would like you to do in class today. We were going to be continuing working on our mitosis lab. I know, yes. But because I'm not here, instead, you guys are going to do a data lab to model how we do a chi-squared analysis, which is a type of statistical test that you use when you're analyzing data and you have an expected outcome. Okay, cool. Get out of here. So it involves M&Ms, which is kind of fun. And you're going to need to work in a group. So the first thing I'd like you to do is to find a group of 3 people to work with. Groups of 3 are fine, 4 are okay, but make sure that if you're going to pick a group of 4, that you are all being actively involved in doing the math and talking about the work that you're doing. That's my only concern with groups of 3 or 4. Groups of 3 are usually pretty good at that. Groups of 4, sometimes there's an odd person out who's not really as engaged. 2 is not enough because I don't have enough M&Ms, and then groups of 5 and stuff like that is just somebody's not going to be as able to be engaged in the work because there's just not enough to do for 5 people. So groups of 3 or 4, find a group. When you do, you're going to open up this chi-squared analysis using M&Ms. Okay, and there's an assignment in there. I apparently need to switch accounts. Sorry about that. Let me log in. Got a lot of Google accounts here. Oh my gosh. I want to use this with Google Drive. There we go. Sorry about that. You're looking at this M&M statistics and a chi-squared analysis. And you're going to need to read everything in here. And there is a lot of text to read, but if you just start at the top and follow along, it should be pretty self-explanatory. It starts off with some data that comes from the Mars company about what we would expect to find in different kinds of bags of M&Ms. So these across the top here, we have different types of M&Ms. The M&Ms I've brought for you all to analyze are plain M&Ms. Okay, right? I just went and got just plain M&Ms, not peanut or crispy or minis or peanut butter almonds or so on. And the Mars company doesn't just sort of randomly place colors in their bags. They have a specific formula that they use for each different kind of M&M that they make, and this is their published formula. So what percent of them are going to be brown or yellow or green or blue? So when the Mars company is making M&Ms, they occasionally want to check to make sure that their expected percentages of M&Ms match their actual percentages, right? And you can run something called this chi-squared analysis to see if that's actually happening. So to do that, we are going to be starting by writing a null hypothesis. It's going to explain what a null hypothesis here. And so you're going to read this and you're going to state a null hypothesis, right? So we have an expected pattern for the data here, what the Mars company says it should be. And then we're going to get an actual, right, an observed amount of data based upon the M&Ms that you're going to get out of that bag and collect and count. So we're going to write our null hypothesis for our experiment here. And there's a template, so it almost just just write it out. I predict there will be no statistical significant difference between, right, describe what, the colors, yes, cool. Okay, that you expect them to be versus the actual data, right? So then to test the hypothesis, we do a calculation called a chi-square analysis. And this is the chi-squared calculation. It's the sum of the observed minus the expected squared divided by the expected value. And for right now, just see that, and we'll move on. We'll do it. It's easier to figure out chi-squared by actually doing it. So lay out a piece of paper. Come up to the front of the room. I should have, I don't know, 5 or 6 kind of larger bags of M&Ms. That means 2 groups or so are going to need to split. 2 maybe, no, that's not right. Maybe I'll have more. In groups of 3, 10. Yeah, so I should have 5. So every 2 groups are going to basically split one of these bags of M&Ms in half. Pile them up on a piece of paper in front of you, right? Share them. So everybody should have every group should have a good pile of M&Ms in front of them. Don't eat any of them right now. Separate them into their color categories, and then record your counts here in this data table in the observed column. That's what you actually have, right? You're going to need to look at your total. So let's say you have 100 M&Ms, right? Then you're going to need to calculate and figure out what your expected values would be. Now, hey. Cole is chasing my cursor on the screen. I'm going to watch him. So I can get him to look at the screen. Yeah, he's chasing the cursor. That's really funny. Okay. So the way you calculate your expected values is by, okay, Cole, that's enough. Is by looking back at what the Mars company said they expected you to find. So if they said they expected there to be 12% brown and you had 100 M&Ms, your expected number of brown M&Ms would have been 12 because it's 12% of 100. Now if you had 120 M&Ms, you're going to need to calculate how many of them should have been brown if 12%. You know, that would be like 14.5 or something like that. M&Ms should have been brown. So you're going to put your expected values down here. I'd like you to round your expected values to 1 decimal point. That will make a difference later on. Next, and your total number of M&Ms here needs to come out equal to the total observed number of M&Ms. So sometimes you're going to need to round up, sometimes you're going to need to round down, but the total needs to come out to be the same. Okay, then you're going to calculate the difference, observed minus expected. Then you're going to square that value for each one, and then you're going to divide it by the expected value again. And then you're going to take the sum of all of those values, and that will be your chi-squared value. And then it's going to tell you down here what to do with that, degrees of freedom it's going to explain, and it's going to explain a little bit how to interpret it. I'd like you to do your best to work down through this stage here where you are either accepting or rejecting your null hypothesis, okay? You're going to need to take some time. You might need to read it a couple of times. You may not even fully understand it. I'd like you to do your best and struggle with it a little bit in the hopes that on Monday, when we're back together again and I go through this, that you will be better prepared to take in information in those places or in those areas where you were confused. Okay, this does need to be submitted before class on Monday. This is an assignment for the weekend.